recorder. Get rid of this one. All right. So what we'll do today is we'll start with the exam questions, the practice questions for exam 2. Okay. And the format of exam 2 is quite different from the first one, because at this point we can write programs. But relax, I'm not going to ask you guys to write programs, in the actual test, because that's really hard to grade. I mean, seriously, it is very hard to grade because most people would turn in a partial solution that does not work entirely. So with a partial solution, how do I score? So unless everybody says if it's partial, just give it a 0. Then it's easy for me again. Right? So, but in terms of partial credit, the most difficult part is to say, okay, this is a partial answer, this is a partial answer. Neither one works, okay? This one answer is missing this and that. That one is missing that and that. So the question is, how should I give these partial answers, scores, so that it reflects, the important part is captured, and okay, you missed a semicolon here. It's not a big deal, okay? So that really is the difficult part of giving you guys actual programming questions during the test. That's why that's not how the tests are conducted. So I have prepared a few practice questions here. I would not say this is the entire test, but it is representative of the kind of questions that you'll be asked in the test. So let me go ahead and show you what they look like. All right, and I can do this entire class using a terminal, because all of the questions are in the form of a text file with a question in comments. So actually, it's somewhat doable. All right, so this is question number 1, and I suppose I can bump up the font size a little bit. Let's go to preferences, appearance, change it to 17. That's good. Is that good? Can you guys in the back read it? Sort of. Sorry? Okay. So this is the code. I'm hoping that by this time you guys find this one somewhat familiar. Is this code looking familiar to you? Mm-hmm. Okay. With certain parts taken out, right? I mean, you used to see this in a somewhat more complicated form. This is actually the easier form of the same code. So I want you to read this code. Okay, the question is, read this code, and then tell me an input. Okay, you have to specify the input the minimum input that will make this program exit. That's it. That's all we're gonna ask. That's all I'm asking. 6 is not gonna do it. Yep.
Are we gonna have can we use a computer?
No.
Or is it gonna be written?
It's all written.
It's all written.
Yep. You're gonna run this program in your organic computer. All right. So the bottom line is, how do you analyze this program to the point where you can say, okay, now I understand the control structure of this program, and this is going to make the program exit. Okay, that really is what I'm asking is, can you, if I give you a piece of code, can you analyze that code, figure out how it works, and then give it the input that is necessary to get it to exit? Okay. Obviously, I have the answer, but I want you guys to kind of work on it a little bit. Okay, where do we start, for instance? Where do we start with this question here? The question is here, okay? Make an input, so give me a sample input that will make this program exit. The input should be just enough to make this program exit, which means if it lacks the last character in the input, the program will not exit. So don't give me, a whole bunch of stuff and say, hopefully, it will exit at some point when it's trying to process this input. That is not, the answer. Okay, the answer is give me the minimum. Okay, if I miss the last character, it won't exit. That is what I'm asking. All right. So what do you think? Where do we start? Yep.
Why do you have if you're asking one, why do you have the counter out there?
Well, That is what the question is asking.
It would still exit if you just say, 66666 5 times.
Nope, won't
Because the
exit.
counter doesn't increase.
Yep, exactly.
So
Okay.
maybe letters or characters that aren't numbers.
Something has, okay. So that's exactly what it is. Go ahead.
You start with the condition of the while loop.
Very good. We start with the condition of the while loop. Because, well, remember, I do not use gotos, okay? And neither should you. Now, without the use of gotos or break statements, which I think nobody should use those, anyway, the only way to get out of a loop is for the condition to become false. Is that making any sense? So when we look at this loop here on line 9, this is the condition to stay in the loop. Okay? As long as counter is less than 5, there's no way we can get out of the loop. So the most immediate question now is, okay, so how do we get counter to be not less than 5 or greater than or equal to 5? Maybe counter starts with a value that is already greater than or equal to 5. Sorry to disappoint you. It was initialized to 0. So 0 is definitely less than 5. So we will get into the loop. So the next thing you have to do is to say, okay, let's find out how counter can increment. And you will find the only place we increment or change counter is on line 16. So now the question is, okay, so how do we get onto line 16 at least 5 times so that we can get out of this loop here, so the counter is no longer less than 5? That really is the question, right? So how do we get to line 16? I cannot get into line 16 until this condition is true. So how do we get that condition to be true? In other words, when you look at standard in or cin right shift to x as one expression, when does it become false? Yes?
We need to enter like a character or something, not an integer.
Right. So the first thing is to ask what exactly is x. Because if x is a char, it can never fail. So you have to first understand what is x. Well, x is an integer. So this part here on line 11 is attempting to read from standard input file into an integer as a base 10 number. Okay, if you don't see anything to change the base, it is always reading in base 10. Yep.
So it's saying while it's not a number, right?
It is saying while fail to read a base 10 number.
Yeah.
So why would a counter increment since it's in the second loop?
How will it increment?
No, why would it not increment counter?
Because if you keep giving it valid numbers, it will never enter this loop. If you say 66, press the enter key, it will attempt to read an integer from standard input file and interpret it as a base 10 number, and it will succeed. If it succeeds, then it returns true. Not true is false, so you don't get into the inner loop. You don't get onto line 14 at all if you keep giving it valid numbers. So you have to give it a non-valid number to get into the loop, right? So once we get into the loop, what do? The first thing we do is to clear, okay? Because if you do not clear, the error status stays and you won't be able to clear it. It becomes an infinite loop basically. So you have to clear first, and then you attempt to read into a char, a character. Okay? Because ch is a local variable, it is just a character, and we can always read into a character unless we are already at the end of a file. Then we increment the counter, and it goes back here and say, okay, I have just cleared one junk character out of the standard input file. Let's reattempt to read the next character as the beginning of a base 10 number and see whether it is successful or not. So if it is not successful, then it will do it again, right?
Yeah.
So how many times do we have to do this for counter to become 5? Or at least 5? 5? No, 5. Just 5 is fine, right? Because we just need counter needs to reach 5, and then it will, that's our objective.
Because it's not less than or equal to?
Because it's not less than or equal to, exactly. Okay. Now, the next question is, if I just give it A, B, C, D, E, and then press the enter key, will that work? The answer is,
Well, you need G.
No, you need spaces in between, right?
No, you also need A, B, C.
let's say that I enter, A to Z, okay, so 26 letters, okay. So none of those can be interpreted as the beginning of a base 10 number, right? So I'm kind of stuck in this loop, 26 times. So counter gets to 26. Hold on a second here. If you keep giving it invalid characters that cannot be the beginning of an integer, I'm not getting out of this loop. The inner loop is not I'm not getting out of the inner loop. What is the only way to get out of the inner loop? In other words, how do I make the condition of line 11 false?
Put in the integer.
Give it an actual integer. So that means A, B, C, D, E, and a 0 will work. The A, B, C, D, E will go into the inner loop, increment counter 5 times because we'll go through 5 iterations. In the first iteration, it will take the lowercase letter A, then the lowercase letter B, C, D, E, 5 times. For the sixth times we evaluate line 11 or the condition of line 11, it will attempt to read 0 as a base 10 number. And that will succeed, right? Because 0 is a valid beginning of a base 10 number. That making any sense? So that will succeed. And so Cin right shift to X will return true because it is successful. What is not true? Not true is false. And when the condition of line 11 is false, what does it do?
Get out.
It gets out of the inner loop. And since the inner loop is the only statement of the entire outer loop, what do we do then? We go back to line 9, and at that point counter has a value of 5. And is 5 less than 5?
No.
No, so 5 is less than 5 is false. We get out of the outer loop and we exit. Yep.
So let's say we start from beginning and we go into the first while loop, and then it asks for the entry, and we just put in the number instead of character. That will remain in the while loop since the counter was not updated.
Yep.
Oh, okay.
But since counter is not updated, you're not getting out of the loop either, because counter is remaining the same as 0
So
all
we
the
still
time.
need to put in those 5 letters.
Yes.
Okay.
Now, since I'm looking for the minimum string to do it, so that means you have to give it 5 invalid characters to start, 1 valid number to end, and that will exit the program. Just giving it an infinite number of invalid characters will not get out of the program because you cannot get out of the inner loop until you give it an actual number. Right? So are there any questions about how we analyze a program like this? I'm starting off with something like this because this is something that we have seen already, right? Because we have dealt with this logic several times already. The first time we dealt with it using Scanf, and the next time we actually use Cin to deal with it. But the logic is still the same. Okay, the logic is the key. The key of this logic is this code here. Okay, you basically throw away the junk character that does not start a base 10 number, and then reattempt to read another integer at the beginning of the loop. All right. So, any additional questions about this one? No. Okay. I'm also giving you guys more questions in terms of the number of questions, because last time I gave you only like 4 questions, and it was kind of hard because for some of those questions you either get it right or get it wrong altogether. So giving you more questions means if you completely answer one wrong, it's not gonna hit your overall grade as much. Okay, because we all make mistakes here and there. So it's that's just something I want to do. Okay, the second one is just asking what is the output of this program, and obviously for something like this, it's really hard to assign partial credit. I can assign maybe 50% partial credit because the output has 2 numbers, I and j. So if you get one right but the other one wrong, I guess I can give you 50% partial credit. All right, so let's analyze this program. This one has to do with the scope of variables. We start off with a global variable I, right? And local variable j in the scope here. So when I say I equals 2, which I am I referring to? The global variable I, because within the scope here there's no local variable I. And then I say local variable j is I plus 1. So j gets a value of what?
3.
3. Very good. Then I enter another scope. I enter another block statement, and each block statement is a scope. So in this block statement, I have my local variable I that is visible only within this scope here. And then on line 10, I say I gets j plus 2. What is j again?
3.
J has a value of 3, so 3 plus 2 is 5. So I has a value of 5. Wait, which 5 are we talking about?
The inner one.
The I that we declare on line 9. Okay, the local I. Yep.
If you were to write this and compile it, the compiler wouldn't complain that there's 2 i's?
No. Because a local variable I is set to hide the global variable I. In other words, when you refer to I, and I is already a local variable, you can only see the innermost definition at that time. All right, so I has a value of 5, so we enter line 12, which has a local variable j. Now that is not a mistake, it can be done, okay? So this j is going to hide the other j, which is defined here, all right? So when we say j gets I plus 1, which I are we talking about again? This I, right? And this I has a value of 5. 5 plus 1 is 6. So this j ends up with a value of 6. So when you output this, it's going to be 5 comma 6. Yep. So that is the correct answer. Okay. Are there any questions about this one? Yep.
So for the j, I mean for
which
the
j?
for the I on line 13.
On line 13.
Yeah, for the I, it always refers to the one on top, the one that goes
The closest
before
one.
Okay,
The closest one.
thank you.
So this I refers to the closest one. It cannot see the global one because we have one that is declared on line 9, which is a scope that is closer to the current scope than the global scope. So just keep in mind, it's the same thing as what you do, is you grab the closest thing, right? So if I tell you, go get a pencil for me, okay? What are you gonna do? You're gonna ask him for a pencil, right? You will look into your own bag first. Darn, I forgot to bring any pencil. Then you ask him for a pencil, right? Then you're gonna ask, the one who are next to here. You're not gonna go to the room 152 and ask Walter for a pencil right away, right? That is basically what scoping is about. Is you look for the closest one first. If there's no closest one, then you go for the global one. All right. So that's question number 2, and here is question number 3. So question number 3, the question is down here. What is the output of this program? This one is a little bit challenging because it is a recursive function. Okay, so this might be something that you want to kind of practice or try to understand during this week, because the exam is on next Wednesday, so you do have about 7 days to prepare for the test. And once again, it is open book and open notes like the first one, and this is also a paper test. So that means you have to get everything on paper, either handwritten or printed, before the test, to get yourself ready. All right, so in this case, we have a recursive subroutine. The reason why I know it is recursive is because in the definition of function f, I am calling function f, okay? So the question now is, what is the output of this particular program? What do you think? Now, first of all, how do you track something like this? It's not easy, okay? It's not easy for even myself to track this just by looking at the source code and try to keep track of all the values that is changing. Just keeping track of everything in my mind. It's just not a very good idea. So what you want to do is to figure out a way so that you can keep track of the values of the variables on a piece of paper. As you execute the code, you have some way to represent the local variables and the parameters on a piece of paper. If you took cisp360 from me, you have a slight advantage because you already know how to do that with tracing. Now, obviously, in this class, I'm not going to ask you for the entire trace, so you can shorthand the whole thing, but keep the principles, okay? Keep allocating new columns for new things, and that way you can keep track of how the program executes. For those of you who did not take cisp360 from me, you can take it from me next semester and then come back to this class. No, I'm just kidding. Okay, so what you want to do is to figure out a way to do it. Okay, so some kind of a notation to help you understand what is going on with this program and how do we keep track of it. Okay, that is what we need to do. All right, so there are several ways to do it. I'm going to kind of try a shorthand way to do it. Let me save this file first, and then we'll get rid of this one. Close and reopen. Accessories, mousepad. There we go. Because I want you guys to have a way to do it on a piece of paper without spending a lot of time to draw the columns and whatnot. Okay, so let's go ahead and figure out what is going to happen when this program executes. So the one thing that I personally would do, at least for the first few times, is to keep track of the execution of every single line. Okay, don't miss one. Don't think, I'm going to skip this because it's wasting time, I have to write it down. Nope, keep track of everything. At least in the practice session, do it. The first line that we execute is line 21. Okay, so we'll say on line 21, we are going to do something. What are we doing on line 21? Eventually, the last thing we want to do on line 21 is to output the value of f of 2 and then the end of line, right? But I cannot do it right now. Why can't I do it right now? Because I have to wait for f of 2 to return, then I know what to print. Is that making any sense? Okay, so on line 21, I'm going to say, okay, we have to invoke f of 2. But instead of just saying f of 2, I'm going to say call f with parameter n starting with a value of 2. That is what I will do. Okay, and then we proceed to which line?
Line 4.
We proceed to line 4 or line 5. Okay. Well, if you want to, you can say line 2, okay, doesn't really matter. But line 2 doesn't do anything, so the only line, the line that starts to do something is actually line 5. Is that okay? I mean, does everybody understand what I'm trying to represent here? Okay, I'm writing down the line number that I'm executing as a log, and then as we go, we try to keep track of the values of the variables. Yep.
Did you just make up 2?
Huh?
Did you just make up n equals 2, or?
No, n equals 2 comes from line 21. Because on line 21, when we invoke the subroutine f, we pass the value of 2 as an argument to parameter n of the function f. Is that part okay? All right. So are there any questions regarding why n starts with a value of 2? It's the parameter. Okay, so on line 5, what do? We say, oh, if n is greater than 0, then we go into the then branch of the conditional statement. Is n greater than 0?
True.
True. Okay, so after line 5, where do we go?
7.
We go to line 7, right? So on line 7, you might want to make a note here. What are we printing?
2.
Okay, so we say output 2. Okay, and then where do we go? Line 8, okay? So line 8, says, now this is the tricky part. The tricky part is how do we keep track of something like line 8? The reason why this is tricky is because line 8 has several things to do. The first thing it has to do is to call f again with n minus 1 as an argument. It has to wait until that invocation comes back, and then it uses the value of that to update r, which is its local variable. Is that okay? So here is the tricky part, because you have to somehow represent that we are executing this statement here, but as a result of doing this, we are now calling f of 1. Is that okay? So you have to figure out a way to kind of keep track of what we're doing on this line, and as a result of that, what is the parameter of what is the new argument 1. Yep.
So basically, by writing the line 8, we say that n, which was 2, got subtracted 1 and now is n equals 1, and then we go back to line 8 to update the r.
Right.
So r equals 1 now?
No. We are not quite done yet because we are not done with f of n equals to 1 yet. Okay, so we are now calling f the second time. Okay, so when we call f the second time, then where do we go?
Like to go back to line 5. And go
Back to line 5, exactly. We have to get back onto line 5 because every time you call a subroutine, you start from the very beginning of the entire subroutine. Now, if I use the same column and the same indentation, it's going to confuse myself a lot. Okay, so what I'll do is I'm going to make this on a separate line just so that I can use a multi-column representation. So what I'll do is I'm going to go here, starting to use as kind of like a new column, okay, to represent the new stuff here. So now that I'm continuing execution on line 5, what I'm comparing n to 0 again. But which n am I talking about? Am I talking about this n here or this n here? N being 1, right? Because that's the closest one. Okay, it is the closest one to me because this is the one that I just created. Okay, so is 1 greater than 0?
Yes.
The answer is yes. Then where do we go? We go to line 7. Line 6, technically line 6 does not really do anything. It's just a marker for the entire block. And I'm going to output something to see out. What am I outputting this time?
1.
We're outputting a value of 1. Exactly, very good. And then we go to line 8. So what is line 8 going to do? We have a local variable r, but remember, I'm using a new column because it is not talking about this r anymore. Now, I'm pretty sure some of you remember, local variables and parameters are on a per what basis? I'll give you two choices. Is it on a per function basis or on a per invocation basis?
Per invocation.
Per invocation, okay? What does that mean? That means every time you invoke a subroutine, you get a new set of parameters and local variables. And that's why there's a new r on line 8, because this is our second invocation. So this r is not the same as the r of the first invocation. Okay? So we are executing line 8, but as a result of executing line 8, we are now calling f again. But this time when we call f, what is the value of the parameter?
0.
All right. And you can see that n equals to 0 here is now on a new column. So right at this point here, okay, I shouldn't say right at this point, but we'll continue execution on line 5. So when we get to line 5, we actually now have 3 parameters available. This is the parameter n of the first invocation. This is parameter n of the second invocation, and this is parameter n of the third invocation. They are independent from each other. Is that okay? All right. Now that we are on line 5, which n are we using to compare to 0? Okay, the one with the value of 0. So 0 is greater than 0 is false. So where do we go?
Line 13.
We go to line 13, and line 13 says r equals to 1. So where am I supposed to put the r equals 1? Should I put it here? Should I put it here?
Yeah, right there.
Or should I put it here?
There.
The rightmost, right? Okay? Because just like there are 3 parameter n's, we also have 3 local variable r's. Because each invocation has a local variable r. The first invocation, which is represented by the leftmost column, has n and r. The middle one, which is the second invocation, has its own n and r. And we are now on our third one, which is the most recent invocation, which also has its own n and r. So when we refer to a variable, it is always referring to the most recent invocation. And this is our most recent one. Okay, so r should be here. Are we still doing okay so far with this representation? I'm not going to ask you guys to turn in the trays. So whichever way you feel is the best way to track down the values of the variables, you can just use that method. This is just some way that I feel is okay for the purpose of doing this. Okay, so on line 13, we give r a particular value, and then on line 14, we just print it out, right? Or what are we actually printing out on line 14? We're not
0.
printing R, we're actually printing N, right? So you got to be careful. So what are we actually outputting in this case? Output 0, very good. And then on line 15, what are we doing? Okay, on line 16, we're returning R 2 times R. All right. What is the return statement with a value? What is it actually doing? Right, the entire invocation that started this one here is now replaced by the value that I'm returning, right? Okay. So line 16 is going to turn one of the invocations into a particular value. I have one invocation here, which is from the all the way outside on line 21. So we have one invocation, 2 invocations, 3 invocations, and that's it. So which one should I replace with the value of 2 times R? What is 2 times R at this point?
2.
Okay, 2 times R is 2. So I'm going to replace something with 2. Which one am I replacing with 2? This one. Okay. So when I execute line 16, I'm going to say that. To keep track of the return value of this particular invocation is changing or being used in what context. Is that okay or not? It's the food truck.
You have bad brakes.
I can identify certain things really quickly. The food truck is one of those things.
So you never actually step into line 9?
Sorry?
Line number 9, you never actually get to it?
Line number 9. Not in this case. Okay, I'm putting a 2 here because the return value specifies the return value of this invocation. Okay, let me finish this first and maybe that will help. Okay, so after line 16, what do we do after line 16 in function F?
Return back to
It's all done, right? It's all done. So when you return from a subroutine, what happens to all the local variables and parameters?
They die.
All gone, right? Okay, well that's easy to understand. What do we do next? When you're at the end of one subroutine or the invocation of a subroutine, where do you go after the end of one invocation? You go back to where it started, right? Whoever called it, whoever invoked it in the first place. So who invoked this last instance or the last invocation of F? It's from here. It's from line 8. Is that okay? So after line 16, we have to go back to line 8, and you can say on line 16 now we have R equals to 2. Because on line 8, which originally called F of 0, now F of 0 is returning a value of 2, so the line on line 8 is effectively saying change R to 2.
and then you have to print it on line 9.
Then we print it on line 9, correct. But this is line 8, so when we get to line 9, we're going to print the value of R, which means what you're printing is the value of 2. Yep.
On line 16, would we write R equals 2, or do we just save that for line 8?
That is a tricky one because you can kind of combine line 16 and line 8 to one single one if you want to. But you need to somehow, because when you execute line 16, you have to jot down a note and say, okay, who is utilizing this value of 2? That is the question. You're basically saying, okay, as an invocation of a subroutine, I'm almost done here. I have a value of 2. But who wants it? Who is supposed to get this value of 2? So on line 16, you kind of have to determine who's getting the value of 2. The other thing you can also do here on line 16 is simply to say return on here, because I'm still dealing with the last invocation of F. So you can basically say, okay, we're just returning a value of 2, and here's a value. Who wants to use it, can now use it. So when you know that you have to return onto line 8, then you know, oh, okay, it is the right-hand side of line 8 that needs to use the value of 2. So you can use whatever representation you want on a piece of paper, but that is what you need to capture, is the end of the execution of f is saying, okay, I got a value of 2, but who wants to use it? And you have to link those two things, at some point. Are there any questions about this?
Can you repeat what you did on line 8?
Sorry?
The most recent line 8, can you repeat what you did?
You mean this one?
Yeah.
Yeah. So this is returning to the last invocation of f is now returning a value of 2. And so it's returning a value of 2, but after the last invocation is done, where am I continuing execution? I'm continuing execution on line 8 because that is what called the last invocation. So when I'm done with line 16, we have to go back to line 8 to continue execution. And that is what is consuming the value that I'm returning.
So pretty much like how in cisp360 we write down the line which would go back.
Yep, pretty much. Except I'm not using the question mark and all the placeholder and stuff like that. All right, so on line 9, we just print the value of 2, and then after line 9, where do we go? We go to line 16, and line 16 is returning a value of what? 4, because r has a value of 2. 2 times 2 is 4. And then where do we go? Okay. How did we get to this entire invocation here? It's from this call, right? And this call originates from line 8. So now we are actually back to line 8. Now when we get back to line 8, this call or this invocation of f is now replaced by a single value, right? Because at the end of the invocation of f, I'm holding a sign and saying, oh, I got the result, it is 4. Who wants it? Right? It is line 8. Because line 8 says, tell me what is f of n minus 1. And that n minus 1 turned out to be 1, so it's f of 1. And now that we know f of 1 is 4, we can now complete the rest of line 8, which is r equals to 8. Then we move on to line 9. Line 9 just wants to output the value of r to standard output. Oops. Take it back. It's supposed to be 4, not 8, not yet. Okay. And then after line 9, we get out of the conditional statement, and then we continue execution on line 16. And on line 16, we say return what? 8. This time we return the value of 8. And who gets it? Remember, at the end of a subroutine invocation, I'm now holding a sign that has 8 in it and says, okay, somebody asked me what is f of 1. Excuse me, this is f of 2. Somebody asked me what is f of 2. I have the answer now. It is 8. But who asked me in the first place?
21.
Line 21. Very good. So now when we get back onto line 21, the f of 2 is here. So line 21 effectively is now saying output the value of f of 2 and then the end of line. So we have 2 things to output. Technically, we got 2 things to output at this point. Now we say output 8 and the line feed, right? End of line. And that's the execution of the entire program. Yep. Go ahead.
Okay, so your original question is what is the output of this program?
Yep.
So we're going to have 2, 1, 0, 2, 4, 8, and 9.
Yes. That would be the complete answer is 2 space 1 space 0 space 2 space 4 space 8 and an end of line character. Now obviously on a piece of paper, whether you leave enough empty spot for 2 spaces or 3 doesn't really matter. I would just count it as 1. So I'm not going to use a ruler and say the average width of a character is 5 millimeter and this looks like 10 to me. So you have 2 spaces, deduct 1 point. I don't have time for that. Okay, if it looks like a space or 3, it's 1 space. Okay. Yep.
Are you going to deduct much points for if you forget to put the end line? I mean, return line.
Well, for me to take a point out of that one, how do you represent an end of line on a piece of paper? If you cannot represent it, I cannot take a point out of it, right? So I'm not gonna. I won't bother too much with the end of line. Any other questions? But the main point of this particular exercise is not the output. It's not the formatting of the output. It is how you track down the value. Okay, there are two things to track down. They're equally important. The first one is to track down the execution of the program, line by line. From here, where do we go? From here, where do we go? From here, where do we go? The second thing to track would be the local variable R and the parameter n. Whenever you invoke subroutine F, a new pair appears. And when you return from an invocation, that disappears. So those are the two things that we need to track with this particular program. And they're equally important because they are intertwined, they affect each other. Are there any questions about this one? No questions? Can we trace this in GDB? Tag, did you give us one of those programs that would not compile or it does not run at all? The answer is no. I actually compiled every single one of these programs and they work the way they're supposed to. So one thing you can do, okay, because the way I use a text editor to represent what is happening here may not make a whole lot of sense to people who like to do it, okay, to like to see it happening and do it, and by doing it, learn it, right? So what you can do is you can actually compile the program and use GDB to track down all of these things. And I'll show you exactly how to do that. So you say G++ -G to turn on the debug option. This is Q2. So you want to specify -O Q2 as the output of the executable, and then Q2.cpp as the source file. You don't have to turn on the warnings and all kinds of stuff like that because we are only interested in tracking down the execution of the program. So GDB Q2 list the program, and this is Q3, sorry. But Q2 is the same way. You can actually execute it line by line and keep track of everything. So this is Q3, so we'll do the same thing except to Q3. GDB Q3. List the program, start a breakpoint on line 21. In other words, I'm putting a breakpoint right at the beginning of the entire thing. So you run the program, it stops right there on line 21. Single step, it goes to line 5. Let me see if I can do this. What I want to do is to display the output of the debugger, kind of more or less side by side with the trace that we have done earlier on paper. So right now we are on line 5 after line 21, and at any point when you're debugging, the nice thing is in GDB you can always ask the debugger, give me the value of n right now. Okay, and we can. Okay, let me change this a little bit. Because people in the back, probably kind of have problems seeing the bottom of the screen here. So this n equals to 2 is representing this n equals to 2 here. Okay, and now, and then we single step because n is greater than 0. We should move on to line 7, which is this 7 over here. And sure enough, we went to line 7. Okay, so it outputs the value of n. So we say, oh, what is n again? Oh, it's 2, and you can see. Well, if you scroll on the other side, n has a value of 2. And then we single step onto line 8. Line 8 is important because line 8 is calling f again with n minus 1. So you say, oh, what is n minus 1? Since n is 2, n minus 1 is 1. So we are now calling with a parameter of n, and we are starting from the beginning of the subroutine again. But this time, because it's a new invocation, it has its own parameter n and its own local variable r. Okay, so when we single step in GDB, it will say that now we're back to line 5, which is exactly what we have logged here. We're back to line 5. But when we are back to line 5, and you say, what is n again? N is now 1. That's because n equals to 1 from the invocation itself. So when you single step, you should also go to line 7 because 1 is greater than 0. And it will print 1 to the output. And oh, Tech, you got something wrong here. We just single step this and nothing happens to the output. Why is that? Because cout is buffered. So it's not like every single time you print something, it will print it to the actual output. It will save it up until it sees end of line. Then it will dump everything at the same time that it has stored up over time. So that's why when you single step, you may not be able to see the actual output of C out because it is buffered. Yep.
But like, for example, on line 8, no, or the one that prints out the C out.
Yeah.
And if we add end line after the,
Then it will print it.
it will print it.
Yep. Because when it encounters end of line, then it will quote unquote flush the buffer and dump out whatever is already saved up in the buffer at that time.
So that's why you didn't write the end line there.
Well, kind of, but without that, your system prompt will be right next to the output. It makes it harder to read.
Mm-hmm.
Yep. I got it ready. All right. So at this line 8 here, you probably know what it will do. It will go back to line 5, but this time n has a value of 0. Now, this is also a good time to try out the command called bt or backtrace in GDB. Backtrace in GDB tells you how we got here. In other words, it shows you all the invocations of all the subroutines that got us here in the first place. So when you look at the backtrace, it shows us that everything started off with main, because you have to kind of read it backwards. So started off with main. On line 21 of main, it called f with a parameter of 2. And then f continues execution until it gets to line 8. Then it calls f again with a value of n equals to 1. And then it proceeds to execute everything up to line 8 again. And then it call f with a value of 0. And at this point, we are on line 5 of the third invocation of f. Are there any questions about how to interpret the backtrace output of GDB? No questions? Okay. In many ways, we have seen recursion, in many, many ways already. How many people know how to use a web browser? Like Firefox, Chrome, no Internet Explorer. You guys know where that one was going. Okay, so how does using a web browser have anything to do with recursion? Can you hit a link of one page that leads to the same page again? Yeah. Would the back button of a browser be able to handle that and say, oh, you came from the same page, let me bring you back to that page? It does, right? It's the same thing here. Every time you invoke a subroutine itself, it's like clicking a link of a web page that brings back the same page itself. Every time you return, it's like hitting the back button of a browser. So there's nothing wrong with it. I mean, you can click on the same link over and over again. The history will keep track of that. This is the history. Backtrace shows you the history of browsing. All right? So in many ways, you guys are super lucky because now we have so many different types of analogies that we can draw from to understand recursion. When I took a class like this using Pascal, does anyone remember Pascal? You can ask your parents. There was no internet. There was no internet. There were no browsers. There were almost nothing in real life that actually resembles, recursion at all. Okay, but you guys are kind of lucky because we do have recursion, in real life, and we do it without even realizing it. All right. So the rest of the execution, I'm not going to trace it because it would just kind of take up extra time. But you are recommended to kind of go through this in GDB and understand what is happening and while this program executes. Okay, that really is important. So I'm going to get out of this one and kind of move forward to the next question. And the next question is question number 4. So Q4.cpp is the next question. All right, so here's another question here. This question is, this one is fun. It says, does this program contain an error at compile time? And if so, what is it? Go ahead.
External int x doesn't define the local variable x.
Well, okay, but we are talking about compile time, so you have to remember the meaning of extern. What does it mean to the compiler, not the linker?
Does it have the x bit?
Okay, the compiler, okay, unfortunately we use G++ as the command to do both compiling and linking. But what is the job of the compiler? Okay, let's think about we are translating a Miyazaki manga from Japanese to English, okay? And it's a multi-volume production. It's Nausicaa, Valley of the Wind. So, who's the compiler? What is the job of a compiler? Translating. Okay, the job of the compiler is just translating. Okay, so in the Japanese form, so let's say one page says, refer to the page number of the second chapter of the third volume. Okay, that's the instruction. The translator says, okay, I'll just leave a space here, right, to be filled in later because I'm currently translating the first volume. Is that okay? That's what extern does. Extern is simply saying, oh, refer to blah, 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 that somebody else is defining. So the translator is okay with that. Not a problem at all. In other words, what if I'm translating a 7-volume manga, okay? And when I'm translating the 4th volume, there's a little thing here that says, oh, insert the page number of chapter 6 of the 10th volume. Will I know at that point is a problem? No, because I'm just translating it. And all I'm going to do is to put a little sticky on the side and say, okay, somebody has to figure out this actual page number, and I'm moving on to do the rest of the translation of the 7th volume. Is that making any sense? The compiler is the translator. So as far as the compiler is concerned, it only has to see this part here and say, oh, okay, somebody, possibly myself, but I'm not sure, will define an integer that's a global variable called x. So when I refer to x equals to 2, that's no problem because x is an integer, 2 is an integer, so I can definitely have an integer on the right-hand side and a variable of integer type on the left-hand side with an assignment operator. So everything is cool, not a problem. So the answer to the first question is no, the compiler do not see a problem. The compiler does not see a problem because extern int x is not an issue that the compiler can resolve. Yep.
Okay, but the second question asks a link time error.
Yes.
You're not linking anything. You don't have a second file to reference that.
Well, let's read the question carefully. The question says, if this program does not contain a compile time error, does it contain a potential link time error? If so, what is it? Okay, the key word here is potential. It doesn't mean that it is always there, but is there a potential problem here at link time?
Yes.
Will the linker come back to this file and say, see, I told you this is going to be a problem?
Yes.
The answer is yes. And why is that a problem? What is the potential problem here? What if volume 10 does not exist? Right? The linker is the one that goes through all the post-its and say, oh, okay, on this page there's a reference to volume blah blah blah, chapter blah blah blah. Okay, where's the page number of that? Hey, the volume does not even exist. So that's a linker issue. And the answer in this case is yes. Okay, this program does contain a potential link time error, and the link time error is x may not be defined by anyone at all at link time. Is that okay? Does everybody understand the nature of the potential error? Now, I only use the word potential here because if one of the object files does define x, then there's no issue at all. Okay, there's no problem then. Yep.
So when are we having an issue then?
Hmm?
When are we gonna have an issue?
When no one is going to define x, everybody says extern.
So if there is no int after the extern, it's gonna be an error.
If everybody is using this and
Uh-huh.
nobody is just saying int x, then we have an issue.
Mm-hmm.
Extern means, I'm just saying that, okay, somebody has this, okay? But without the extern, I'm saying I am the owner of X. But I'm willing to share, so everybody can use it. It's a global variable. Yep.
So without an extern, it would work perfectly fine.
Without the extern, without the extern, I would take, both yes or no as an answer, as a valid answer, because I'm asking what is it, right? Now, with int x, you can still end up with a potential link time error, because what if another file is saying exactly the same thing, int x? Now you have two global variable x, and the linker cannot decide which one to use. It's the same thing as having two volumes, like two volume tens. Okay, so which one are we talking about?
So it needs to be static.
Hmm?
So then it needs
So
to be
one
static.
has to be static. That's one way to solve the problem, right?
And this program is just going to print 2.
This program is just going to print 2. Exactly. Yep. It's not going to do anything particularly useful. Yep. All right.
Just a quick question.
Yep.
So the extern in your manual on the website,
Mm-hmm.
in which category is it? So I can
Extern is under the lifespan and scope of variables. And it's under the first one, which says global variables are evil or something along that line.
No, thank you.
See, if I taught this class out of a textbook, I would not remember at all. It's like, where in the book? I don't know. Let's look through the index. All right. So that's question number 4. Let's move on to question number 5. All right. This is question number 5. I really like question number 5. You may not agree, but it's a combination of the concepts that we have talked about in this class. Okay. It's combining printf, scanf, and the calling of subroutines with recursion. So I would definitely kind of rank this one as one of the more difficult questions. And in the test, all the questions will have equal weight. So you should definitely go through the whole thing, pick out all the easy ones, and then work on the harder ones later. Okay. All right, this is definitely one of the harder ones, depending on your perspective, but I would definitely agree that this is one of the more difficult ones. Okay, so this one has recursive function call, because we have function f, and inside we call function f again. And it depends on the input. Okay, so the input dictates what it's going to print. So the question, oh gosh, I forgot to ask the question itself. Okay, so let's say, I'm going to give you the question here. The question is, what is the output of this program when the input is 1, 2, 3, and then the line feed character? I'm going to use LF as a line feed character, or the carriage return. So I press 1, 2, 3 on the keyboard, and then I press the enter key. What is this program going to print? That's the question. Okay. All right. What do you think? And by the way, the program crashing is always an option. You can always say the program is going to crash. There's no output. Well, if it is not matching the actual output, then that answer won't get any points. All right. So how do we get started with this one? Well, we track it down. We trace it just like before. Okay. So what we do is we'll use one way or another to represent all of this. So in this case, we start execution on line 19, right? Line 19 says printf, blah, blah, blah. You don't have to repeat exactly everything here, but this part is important, okay? Because this is going to call, it will call f of 0. Okay? So this is the beginning of a new column. Okay? So when I call f, what is going to happen? We start execution from where? from the beginning of the subroutine that we are calling. And in this case, what is the first line that actually does something? Line 6 is the first one that does something. Now, but you do have to remember, by the time we get to line 6, we will have parameter n, local variable r, and local variable ch existing. The values of r and ch are unknown because they are local variables, and I don't even bother to initialize them at this point. But they do exist at this point. Okay, so the trace does not really reflect that because it's a simplified version of a trace. Okay, so on line 6, I'm going to do a scanf first. Remember, every time we have conjunctions, it is always evaluated from left to right and using the short-circuited evaluation. Okay, in other words, with a conjunction, as soon as we hit a false expression, it stops and just say, oh, the whole thing is false. Don't bother to evaluate anything to the right-hand side. So the first thing we'll do is to do a scanf %c. What is %c specifying when we are using scanf?
Character.
A character. Okay, I'm reading in a character. And where am I reading the character into? Local variable ch. Okay, very good. And if I type in 8123 and then press the enter key, what is the first character?
1.
1. Okay, very good. So, but what is the return value of scanf in this case?
0.
Yeah. What does it represent? Scanf returns the number of things that it was actually able to read. And did we read anything? We just read the ASCII code of 1 into ch, right?
Mm-hmm.
So what is the number of things that we just read? Exactly 1. But since I'm using 1 in the context of logical AND, what does that mean?
True.
True. Okay. If it is a true and something, should I evaluate that other thing, or should I just say, the whole thing is true? We have to evaluate the other thing, because with conjunction, you have to wait until you see a false, okay? You cannot make a conclusion until you hit a false. Okay. Or finish the whole thing. Okay, so we did read one thing, this expression returned exactly 1, and the character that we have just read is now in ch. Now we evaluate the second expression in the conjunction. Is the ASCII code of 1 less than or equal to the ASCII code of 3? Yes, okay. So now we have true and true. Can we get out now?
No.
Yeah, okay. This is the last one, right? Is the ASCII code of 1 greater than or equal to the ASCII code of 0?
Yes.
Yes. Okay, so now we have true and true and true, which is
True.
true. Okay, very good. So if the condition is true, we go to the then branch of this statement, which is on line 8. Okay, so let's keep a log of that. So we say on line 6, the only side effect I have to remember is, ch is now has the ASCII code of 1. Okay, so now we move on to line 8. And line 8 is, wow, it's kind of funky. What is that? Okay, so let's try to figure this out. Okay, let's figure this out one by one. N times 4 plus ch minus quote 0 quote. Okay. All right, let's do this one thing at a time. What is ch again?
1.
The ASCII code of 1. It's not the value 1, it is the ASCII code of 1. And what do you think is the ASCII code of 1 minus the ASCII code of 0? Oh, Tag, you did not give me the ASCII code table. I cannot figure this one out.
That's what I'm thinking.
Well, the ASCII code of 0 to 9 as digits is one single block, and it's sequential. So that means the ASCII code of 1 is 1 more than the ASCII code of 0. The ASCII code of 2 is 1 more than the ASCII code of 1, and so on. So what if I tell you that? Then what is the ASCII code of 1 minus the ASCII code of 0?
-1.
That's the value of 1. Okay? All right. So this is just 1. And what is n again? N is 0 because it is a parameter. It was given to me. Okay? So n is 0. 0 times 4 plus
0.
1. Okay, so I think I can figure this out. That's just 1.
Wait, 0 times 4 is 1.
0 times 4 is 0. but ch minus quote 0 quote is 1. So this whole expression is 1. Oh, okay, so we are calling f again, but this time with a parameter of 1. All right? So this whole thing is becoming, okay, this is r equals to that whole mess here. So let me line up everything so it looks right. Okay. So that means this is going to call f again, and this time with the parameter n starting with a value of 1. Are we doing okay so far? And the rest is, well, guess what? Not much different. Because we end up on line 6 again. And this time on line 6, what are we reading? We have scanf again. So this time, which character am I reading? 2, the digit 2, right? And is the digit 2 less than or equal to the digit 3? Yep.
Are we to do value 2 or the ASCII value?
The ASCII code of 2. Yep, the digit of 2. So we are dealing with the ASCII code of 2 in CH. Is that less than or equal to the ASCII code of 3?
Yes.
Is it greater than or equal to the ASCII code of 0?
Yes.
Okay, so we're going to go to, from line 6, where do we go? From line 6, we go to line 8 again. And line 8 looks like a big, huge mess, but this time we know how to deal with that big, huge mess. So on line 8, we're going to say r equals to f of n times 4 plus ch minus quote 0 quote, close paren, close paren. And now it's just a matter of figuring out, okay, what is n?
1,
N is 1. And what is ch?
2,
The ASCII code of 2. And what is the difference between the ASCII code of 2 and the ASCII code of 0? It's just 2, right? And what is 1 times 4 plus 2?
6.
All right. So we want to figure out what is f of 6 this time. Cool. And that's going to call the subroutine f again, right? So we say calls f again, but this time n as a parameter equals to 6. Not surprisingly, we end up on line 6 again. And we'll read in which character? We just read 1 and 2. 3, okay? The ASCII code of 3 is now being read. Scanf returns a 1. The ASCII code of 3 is less than or equal to the ASCII code of 3 is less than or equal to true. The ASCII code of 3 is greater than or equal to the ASCII code of 0 is true. So we got true, true, and true. So the whole thing is true. Then we get to line 8 again, right? Yep, go ahead.
Is there any particular reason why you put it in parentheses this time? The 1 times 4 plus parentheses, quote 2 minus. For the first one, you know.
I put quotes around this so that you guys can associate, we are dealing with the ASCII code of one thing minus the ASCII code of the other thing. So it's easier to look at it this way.
I'm asking between that one and the one right above it.
Oh, you mean this one? That doesn't matter. You can put.
No, the first time you invoked f of n equals 0.
Oh, okay. You mean here?
Yeah.
Yeah, I just forgot. So that.
No, you see the first time you invoked f of n equals 0, and then you put ch equals quote 1 there.
Oh, it's the same thing. I just sometimes I rewrite the entire thing. Sometimes I just rewrite the
I was just
portion
wondering
that I
if there was a
change.
difference.
Okay, so now we're on line 8 again. So this time on line 8, we have to do pretty much the same thing, right? R equals to f of n times 4 plus ch minus quote 0 quote. And we are running out of space. Okay, so missing one close paren here. All right, so what is n? N is 6 times 4. And what is the ASCII code stored in CH? It's the ASCII code of what? 3. Okay. And 6 times 4 is 24. Plus 3 is 27. Okay. So this means it's going to call f again. But when it calls f, n equals to 27. That's taking a lot of space. So bring extra paper. All right. So we are invoking f again, and where do we start? Line 6 again. All right. And we'll go to line 8. Oh, wait. Hold on a second here. This time it's not the case. Okay. So this time on line 6, what are we scanning? Okay. Let's take a look at the question again. The question asks, if I press 1, 2, 3, and then the enter key, what is the output? I have read 1, 2, and 3. So this time, what am I reading? The line feed character. Okay, I'm reading the line feed character into CH, which will result in a successful scanf. So scanf is not a problem because the line feed character is just a character. Okay, but do you think the line feed character is between the ASCII code of 0 and the ASCII code of 3? What is between the ASCII code of 0 and the ASCII code of 3? 0, 1, 2, and 3. Is line feed anywhere in between? No. So it would fail the last condition actually. But it will definitely not succeed in this entire thing. So what does that mean? Where do we go? We go to else, which is line 12, right? So now we go to line 12. And what does line 12 do? Line 12 says R gets N, all right? So which R are we talking about? Because each invocation, this invocation has a R, this invocation has a R, this invocation has a R, and this invocation, which is partially visible, also has a R. So where do I put R gets 27?
The very last one.
All the way to the right-hand side, right?
Yeah.
Okay. This is the important part because everyone has an R. This is the one that gets the value 27. And then where do we go after line 27? After line
14.
Line 12. Yeah, after line 12 we go to line 14. Okay, line 14 doesn't seem to do much. All it's going to do is to return the value of R. So we'll say, okay, I'm holding a sign here that says 27, but who asked me about this question?
The previous R.
It's the previous one. Okay, so where do we continue execution? How do we get here to begin with? Who called me? It was R equals F blah 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 on line 8. So that means after this return statement, we go back to line 8. We try to finish up this statement here. Okay, now when we get back to this statement, what is this value? What is F of blah 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 blah? It's exactly 27. Okay, so that means this statement on line 8 is now just saying R is getting 27. After that, we get to line 14, and on line 14, it is returning R again. And guess what? R does not change the value. It is just returning 27. But who asked me this time?
Line 8 again.
It's this one, right?
Yeah.
Because this entire invocation is because of this call, and this call is coming from line 8. So we get back to line 8 again. And line 8 is essentially saying R is 27, because this whole chunk here is 27. All right? Okay, I know we are running out of time. We only got about a minute left, but that's all that we need. Because after this line on line 8, we get to line 14. Let's get back to the original code just to show you. This is line 8. After line 8, we get out of the conditional statement, so that's why we get to line 14. So we get back to line 14, and we say, oh, let's go ahead and return the value of R, which is, again, 27, right? And who wants to use this value of 27?
The very first.
Who called me? Okay, so this is the invocation returning, and this call tracks down. Oh, so this is how we got here on line 8. Back to line 8, and line 8 becomes now R just R is 27, or R gets 27, and once again we get to line 14, and we just say, oh, return whatever R is, which is 27. And who wants to know that? Who called me? Line 19, right? So now we get back to line 19, and line 19 is printf blah 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 27, and that blah 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 is %d\n, right? Which simply means I want to print 27 as a base 10 number. So the output of this program is just 27 in base 10, which coincidentally, I shouldn't say coincidentally, which is 1, 2, 3 as a base 4 number. That's why you see the multiply by 4, thing. Yep.
How many of these questions are we going to have?
I do not know yet. There'll be at least a few of these,
In 1 hour?
1 hour and 15 minutes. So, are there any questions about this one? And by the way, this one compiles and runs too. So if you want to trace it, okay, it may not be a bad idea to track it down because a lot of times it has to do with doing it several times, through GDB, or using just a text editor like this. All right. All right. So if you guys have any questions, do not hesitate to ask. I keep forgetting to create a forum so that you guys can ask questions in a forum for this class. You can definitely email if you need to. So we'll have next Monday to finish up the other test questions, or I will go over those, and produce the YouTube video, so that way you have the answer to the other test questions, the practice questions. So then on Monday, if you have any questions about the concepts or the scope of the test, on Monday will be the last class to ask before the exam. All right. Test is on.